Okay, so we're looking at the only application we have to look at in Year 11 methods, and that's the application of antiderivatives to motion of a particle. Okay, so movement. Okay, movement of a particle. Okay, so just some definitions for the people who don't remember their physics from Year 10 or this year. Okay, so the words we're going to use are displacement, and that's how far the object is from the origin. Okay, the object could be a particle or whatever. Velocity is how fast the object is moving at time t. So the variable is time, okay? The variable is time. So in previous things, the variable's been x, like when we have y equals x squared, the variable's x. Now in these ones, the variable's time, so all the formulas will have the letter t. Now, and the last one, which you're maybe not really sure about, is acceleration, and that's the measure of how the velocity is changing at time t. So displacement is distance, it's how far away from the origin. Velocity is how fast the displacement's changing, and acceleration is how fast the velocity is changing. Okay? So they're all about rates of change, and rates of change is calculus. Okay, so if we were going, just to clear that point up, if we were going from displacement to velocity, we would derive, and if we were going velocity to acceleration, we would derive. But what we're going to be doing is going backwards from the acceleration back up to displacement. So copy that down and come across when you're ready. Okay, so again, just as I said, so displacement, we use the letter S. Well, I'm not too sure what the book's going to use, but I use the letter S. V for velocity and A for acceleration. And the variable is time, is the variable. Okay, so all the formulas will have T as the variable. So when we go down, we derive, and when we go up, we integrate or anti-derive. Okay, so if we want to go from A to V, we integrate. We can't go from A to S directly. We've got to go from A to V and V to S. There's no connection between A and S. Okay? So let's have a look at an example. So copy that and come across. Okay, so this is the example we've got. A particle's acceleration is a constant 5 meters per second squared. Now this is just the unit of acceleration. So m is the distance, like that's what distance is measured in, and seconds is the time. Okay, and that's how you measure acceleration, meters per second squared. So acceleration is meters per second squared. Velocity would be meters per second, and distance is just meters. Okay, so its velocity after 1 second is 6 meters, so we're going to use that to help us find the value of the constant, and its position initially, so after 1 second, that's time, we know its position, and this is initial, which means time equals 0. We'll come back to that. So this number here will help us find the value of the constant. Okay, so they'll come back in. So what we have to do is we have to find the velocity at any time and then the velocity at a particular time. So we're going to use the formula that we create, and here we're going to find the formula and then use the formula that we create. Okay, so copy that question because I'm about to move up a little bit. Okay, and people are going back and up and back. Okay, change colours. Go brown. Okay, so acceleration is 5. Okay, it says it's a constant 5. So straight away, we know that the velocity. Now, so when this is just a number, so that means that when we integrate, like a number just turns into, we just put the variable. When we had, just to remind you, like when we had say y equals x plus 2, the derivative was y equals x plus 2, we add 1 to the power, and then 2 just turns into 2x. So when you have a number, you just add the letter. Okay, so if you have a is 5, then v equals 5t plus a constant, because we don't know what happened. So just to make sure, when we had a number with the, and we were trying to anti-derive, we just add the letter x. So when we have a number, we just add the letter t, because that's the variable. Now, to find the value of the constant, we go back to the initial information. So its velocity after 1 second is 6. Okay, so what we do, its velocity after 1 second is 6. So 6 equals 5 times 1 plus c. 6 equals 5 plus c. So c equals 1. So the formula is v equals 5t plus 1. So that's our velocity formula. We use the information to find the value of the constant, and then once we got that, so that's the answer to A. The answer to B will be at 10 seconds. So velocity equals 5 times 10 plus 1. So that's 51, and the unit is meters per second. Okay? So we, just a few things. So a number, just add the letter, and then plus the constant. Then you work out the constant from the information in the question, and then you use the formula. Okay, so now we've done the first two, we can now look at displacement. So we've just got to see, just got to take this information. So that initial is 7. So we need that information. So I'm just going to move the board down a bit. Okay, so we're going to go from velocity to displacement. So S equals, so 5t turns into 5t squared over 2. 1 turns into 1t, or just t, plus a constant. Okay, and it says in the question that its initial position is 7 meters. So 7 equals 0 plus 0 plus c, because time equals 0 initially. Okay, so time equals 0 initially. So we end up with c equals 7. So the formula is 5t squared over 2 plus t plus 7. So that's our displacement formula. And then to finish it off, we use the last part, which is t equals 3. So that's the answer to C. And then in D, S equals 5 times 3 squared over 2 plus 3 plus 7. 9 fives are 9. 5s are 45 over 2 is 22.5 plus 10. So its position at 3 seconds is 32.5 meters from the origin. So wherever the origin is, like that's the origin, the particle is at 32.5 meters. Okay, so that's what it means. Okay, and we'll have some questions either from the book or from Moodle for that, and that's our last slide is blank. Okay, so that's the last slide. Okay, thanks, bye.